Today we're going to talk about how to write an equation if we are given a transformation. So that means that we could be given the graph, or we could be given in words or in writing what the transformation is. So to start, we're just going to look at a couple examples of graphs. So the directions say, each graph below shows a parent function. The parent function is the solid line. So the first one here is my parent function. And a transformation of the parent, which is the dotted line right here. Write the equation of the transformation. So the first thing that we're going to do is just make sure we identify the parent function. Hopefully we're getting better at this. From our family of functions, this first one is my V-shaped graph. I know that that is the absolute value graph, so I'm just going to write here that the parent function is the absolute value of x. Now, to write the transformation, we have to first identify what the transformation is. So I'm just going to see here, okay, so from my parent graph, from 0, 0, I move left, and this is pretty small, but I can see that I move left 4 units, and I move up 1 unit. So I'm going to write U1, left 4, up 1. So I just have to figure out how to write that equation with a left 4 and an up 1. So I know my equation is going to start like this with the absolute value of x. And I'm going to leave a little bit of space here because I know I have a transformation inside my function. So I'm going to write something here and here. So inside my function should be my left or right shift. Left, even though it means negative on the x-axis, I use the opposite symbol. So that would be plus 4. And up 1 just means at the end of my equation, I write plus 1. And that's my final answer. Y equals the absolute value of x plus 4 plus 1. All right, next example. I have a parent function right here, my solid line, and this shape kind of looks like half of a parabola on its side. That is my square root function. So my parent function is the square root of x, and my dotted line here is my transformed function. So I'm trying to identify what that is. The first thing I hope that you notice is that see how my function flipped upside down? That's a vertical reflection. Okay, so I'm just going to jot down that this is vertically reflected. So I'm going to write vertical reflection. And then the other thing I notice, if I look at my origin right here of my parent function, do you guys see that the new origin or the new key point is shifted over? So I'm going to put a little arrow and write R1. This is shifted right 1. So we moved right 1 and we're also vertically reflected. So it's the square root function. So to write our equation, I'm going to write y equals, the square root is going to go here, and I'm going to write x, and I'll leave some space. I'm going to figure out if I'm going to put my shift in here or out here. So vertical reflection, if you remember, means that we put a negative outside of our square root. So there, that's done. Check. Right 1 means that underneath my square root symbol, I should have a shift within my square root symbol, and right means that I should shift minus 1. And I like to make my square root symbol end like that, just to clearly show that I know that that x minus 1 is within my square root symbol. And that's my final answer. All right, last one. So this one, my original function, hopefully we're getting good at noticing this one, very popular. This is x squared, it's a quadratic. And my shift from here, looks like I go left. I know this is tiny, but it looks like left 4, and then also down 4. So left 4, down 4. So I'm going to write y equals, there's no reflection, so no negative symbol. And when I write x squared this time, I'm going to put it in parentheses like this, because that helps me remember that there's going to be a shift inside my x squared and also outside, and I decide which one is which. So the inside reflection should be my left or right. So left 4 goes inside the square root. or inside the parentheses, and left 4 would mean plus 4. And then the down 4 means that I subtract 4 outside of my function. All right, and there's my final answer. We just have more practice problems. So you might want to pause the video and try these ones on your own. The only difference for these is that you aren't given the original. So if you recognize the shape, right? So I recognize this shape. Just remember that all of our family of functions that we've studied start at the origin. So what you're trying to figure out is from the origin, how far this graph shifted. So from here, it looks like I go right and up. That's what you're trying to figure out. So if you want to pause the video and try these on your own, that's great. Otherwise, you can just listen to the answers. So for this graph, I know that this is x squared, y equals x squared, and it is shifted right 3 and up 1. So when I write my final answer, I'm going to write y equals, there's no vertical reflection, x right 3 would actually be minus 3, and that's inside the parentheses before I square it. Up 1 would mean adding 1 at the end. All right, and the next one, this one's a little bit tricky. I notice this squiggle, right? I know that that squiggle is my cubic graph. I know this is x cubed. But the thing with x cubed is that its original goes through the x-axis. I'm going to draw the original in red here with a dotted line. But the original is increasing. So this isn't x cubed exactly. What happened is that x cubed, my original, is flipped over the x-axis. So this is a reflection of x cubed. And my original, my parent function, and the new one, the solid one, actually both go through the origin 0, 0 as their key point, their central point, which means that there's no other shifts. So I'm going to write here, there are no other shifts, only a reflection. So for our answer, we would write y equals negative x cubed. It's just reflected. Our last example is just without the visual. So if you're given an example like this, you'll have to be given some details. So this one says, write the equation for the transformation of the square root function, which is y equals the square root of x, that's my parent. And I want to shift it 3 units right and 2 units up. Okay, 3 units right, 2 units up. So I'm going to say y equals the square root of x, and I'm going to leave some space under my square root symbol. Inside my square root symbol should be my left or right shift. So 3 units right should go inside, and right I know is subtraction, so right 3. 2 units up should be outside my function. So outside, I'm going to make sure that it's clearly indicated on my paper that my square root symbol ends, and then I add 2 after it. So the x minus 3 is clearly within the radical. The plus 2 is outside. All right, that's it for today. You guys will try a little bit of practice on your own. Good luck.